Welcome back to the morning show. We're still having this discussion on the decade from earlier because I still contend I'm right.
And you are.
Okay, good. That's all. Settled. Done. All right, chemistry lesson time today. We know it's cold outside and all that good stuff. You're talking about the Celsius and Fahrenheit.
That's right. We're going to talk a little bit about temperature, and we got these crazy systems here, Celsius and Fahrenheit, which turned out to be somewhat arbitrary.
Okay.
I mean, well, they're not completely arbitrary, but when they came up with them, it was kind of wacky.
Really?
Yeah.
Okay.
And, well, you know, temperature, when we talk about temperature, what exactly is that? What are we measuring? And you know, the scientific answer would be that you're measuring the average kinetic energy of whatever it is you're measuring.
Sure.
So the air and whatever, and it just so happens that it's not an absolute measurement, though. I mean, you can't just calculate on a piece of paper what the temperature is based on, you know, I suppose you could, but it'd be very difficult. So what we do is we have an analog, okay, that we come up with in order to give it into some sort of measurement that we understand.
Right.
Okay, and the first person to do this, well, not the first person to do it, because Galileo invented a thermometer, but it didn't work very well. Back in the 1500s or 1600s. Along came a glass blower named Fahrenheit, Gabriel Fahrenheit, and he invented the mercury thermometer and an alcohol thermometer the way we have them now with the little bulb and and everything like that. And so he wanted to come up with a way to calibrate it. And he based it on an earlier guy's named Romer's work, where he set 0 as this point where you take a mixture of ice and ammonium chloride, which is the coldest thing they could get in the lab that was steady temperature. Okay. Okay. So they set that at 0, and you can see this is pretty close to 0.
Yeah, you're getting there.
Okay, because I have a mixture here of ice and ammonium chloride. So they set that at 0, and then he set the temperature of boiling water at 60. I don't know why. They had a lot of weird things about 60s and stuff like that. Well, it was originally done 360, so that's the reason why we call them degrees. But anyway, he made it 60 degrees. And then, well, Rankine thought that he wanted to have something that more appropriate. He was a weather guy. He made instruments for weather. So he wanted to come up with something that we'd be able to tell weather with a little bit more appropriately. So he used the same 0 point that Romer did, but he set the human body temperature as his high point, and for some reason used 96. He didn't use 100, he used 96, and that was he measured his wife's temperature in the armpit.
Got it.
Anyway, he came up with 96, and that put freezing water at 32.
Okay.
Okay.
I got you.
And the reason why he did that, or he actually, it was 30 and 96, but he made the freezing point of water 32 and recalibrated so that he would have 64 degrees between 32 and 96 because you can divide that.
Yeah, it works out evenly.
You can divide it and divide it and divide it and divide it and have nice fine measurements. Okay, so this is the kind of wacky system that these guys came up with. It's completely arbitrary. Well, that put boiling water at 212. Okay, which is why we have that. And it's 180 degrees between freezing and boiling, and that was really convenient. So that's the reason why they went to that. Along came Celsius a little bit later in the mid-1700s and decided he would use water, freezing point of water is 0, and boiling water at 100. Actually, he said 100 for freezing and 0 for boiling, and then swapped it the next year. Okay, and he was basing that because that's what Newton wanted it done.
Okay.
Okay, so then you had a nice 100-degree shift. So that's the reason why a degree Celsius is a lot more, you would say, you know, so to speak, than a degree Fahrenheit. I mean, and because they used the two systems. And then Lord Kelvin came along and
blew everything out.
No, he just said we need to find what absolute 0 is. And so they used the Celsius scale but put 0 at absolute 0, which put 0 degrees Celsius at 273 Kelvin.
Wow. That's a nice history lesson just to tell you it's cold outside.
Yeah, it's cold. But it's not as cold as it's going to be with liquid nitrogen when we come up.
All right, liquid nitrogen fun coming your way. We're going to freeze some stuff and freeze a banana and pound a nail with it?
Yeah.
Sweet. All right, do you want to see a replay of this? Go to our website.